we are going to talk about what is IEC 61215 and 61730 standards, and what is the purpose of the test, and what test instruments will be used for these tests, and how to test it. And in the end of this presentation, we are going to take you guys to our laboratory, and we have all the equipments there, and we will show you the equipments and explain the test SOP and answer questions in the end of the session. So typically we perform quality inspections on PV modules in the following aspects. And the first one is we will perform efficiency test. And the second is we will do electrical performance test. And the third one, and we will do mechanical stress test on the solar panels. And we will do environmental agent test on the solar panels. And last but not least, we will do a light-induced degradation test on all of those solar panels. Among these 5 test categories, and some of the tests belongs to the test requirements of the IEC 61215, and some of them are from IEC 61730, and some of them are from the requirements of incoming material inspection and before production. And in the end, when the module got delivered to the installation site and in operation stage, we will also need tools to run checks on the panels as well, as we call it maintenance routine. So without further ado, let's go into the content. And meanwhile, remember to leave us a message in the message box or get direct contact via WhatsApp. And we will answer questions in between or after the session. And so the flow chart on the right side and shows the IEC 61215 test standard process, and it consists of 6 test sequences, and each with a different test procedure for a total of 22 tests. And before a new model of solar panel is released to the market, it is required to send to an authorized testing organization, and such as TUV, UL, or CQC certified laboratory, to complete all the tests under IEC 61215 test procedures before sending these sample to these organizations for the certificate. We need to complete these tests in our own internal laboratory just to ensure that our samples are qualified and can be sent for certification. Each IEC 61215 test requires different test equipment and to complete the test. And today we will discuss all the tests under these test standards, and we will show the device in the end of this presentation session. So what is the purpose of the IEC 61215 standard? And this standard actually is to determine whether the electrical or thermal performance of the module is good or is fine, and to prove that solar panel can be used for a long time under a specified climate conditions. And Millennial Solar, actually, we offer all the device that is deemed to apply these test standards. So what kind of device will be used under this test category 61215 procedure? So the core products will be chambers like the HF chambers and DC chambers and the TC chamber as well, and some mechanical tester like mechanical load tester, dynamic one and static one, and the Hell tester and module breakage tester, and some light simulation chambers like the steady-state solar simulator and the UV chamber. Yes, and some devices for electrical performance checks like the bypass diode tester and the HEPA insulation and the grounding tester. And for the R&D team, when you're developing a new product, a new process and the new raw materials will be switched from the old one probably. So at this time, we will need to use testing equipment to verify the quality and the reliability of the new products. And as for production, products also need to be continuously inspected and verified during the production process, just to be sure that the reliability of the products meets the requirements of the IEC standards. And at the same time, the actual test data will also ensure the credibility of the products and improves our sellers' competitiveness of the products. Next, let's take a close look at the application scenarios and equipment that is required for these international standard tests. I will take you guys from the IEC standards MQT1 to MQT22, which is the complete test procedure under the IEC 61215 standard. So start from the IEC 61215 MQT1 visual inspection test. So what is visual inspection test? So visual inspection test is through a visual inspections on the solar cell or module, and under a specific STD situation, which is you need the lighting of no less than 1000 lux to check the cell or the module if the cell has breakage or cracks. And as for the module, you need to use these tables and in this situation to check if there is bubbles or delaminations on the module. And of course, and as the junction box as well. So for this device, as you can see from the picture, is wielded, which is movable, and you can move this table around the production area if that is required. And we have some drawers over here, and this is can store some small tools to make this table more needy. And the other perks of these instruments is we are using LED fluorescent lamps, which these type of lamps offers much longer lifespan. Okay. Next, we come to the MQT2 and to 4 and 6, and this is what MQT2 is the maximum power measurement, and MQT4 is temperature coefficient test, and MQT6 and 7. MQT6 is SAT, which basically is standard condition of test to make sure we have that prepared before the test. And 7 is performance test under low irradiance. And the device we need is IV tester. We call it IV tester, and some call cell tester or solar simulator. This instrument is mainly used for electrical performance of the solar cell and the module test by testing its volt-ampere characteristic curves and its maximum power and maximum power point current and maximum power point voltage, etc. And then you can tell its electrical efficiency and performance of the solar panels. And for this device, the advantages that we have is integrated capabilities. Basically, we combined all the performance electrical tests within this one machine. Next one, MQT3, is insulation test. Insulation test is a very simple device, and I'm sure everyone knows how its application. So basically, when solar cells are used as a power device, the insulation between the charged body and accessibility part is very important. So insulation with stand voltage test, it is required before you send the solar panels to the market just for the safety, electrical safety purpose. And for this device, we have two options. One is a 3-in-1, which contains insulation and the voltage resistance and the grounding test. a 3-in-1 product. And we have the simpler one, and this one we usually pair this with our wet leakage current tester. It's just insulation and voltage resistance test. And its withstand voltage is DC withstand voltage is 0 to 12 kilovolt. Okay, and now we are at MQT8 outdoor exposure test, and this chamber can also conduct MQT19 test, which is the stability test, and we call it a steady state solar simulator. So what is stability test? And this scenario is used to simulate the ability of solar cell or modules after being exposed to outdoor sunlight. And under this condition, it may reveal the comprehensive alternation effect of that cannot be measured in the laboratory test. And it can also be used for module hotspot durability testing and caused by defective cells and mismatched cell as well. And so these chambers advantage is that its irradiation intensity can reach to 1,300 watt per square meter, and it's stepsily adjustable from 30% to 100%. And we are a multi-channel chamber. We can customize the channel according to your actual needs. But due to its restriction of the container, when you're doing sea ship, when you're doing ocean ship, then we have to limit the channels under a certain amount. Probably like you can do like 12 channels, and that will be the maximum usually. Okay, MQT9 hotspot durability test. Okay, so what is a hotspot durability test? And this test is mainly used to evaluate its ability of the PV module to resist hotspot effect. Okay, ensure its reliability and the safety of the module during its actual use. And for this device, the one I have to mention is the accuracy of our sensor, and is plus and minus 0.2 degrees Celsius, and its measurement accuracy is plus and minus to 5%. Now we are at MQT10, UV preconditioning test. So for UV preconditioning test is mainly used to test polymer materials inside the encapsulated solar modules, materials such as the EVA, the EVA, and the silicon, and the backsheet, junction box, solar cells, and cables. And these materials will change their performances after the long-term UV exposure. So that's why we have to do a pre-simulation, and just to verify its performance is as we expected. So our UV chamber is spectral range is from 280 to 400 nanometer, and its irradiance is 150 to 250 watt per square meter. And we have a super UV preconditioning chamber, and its irradiance can reach to from 200 to 600 watt per square meter. For MQT11, thermal cycling test. So thermal cycling test is to assess a module's ability to withstand thermal mismatch and fatigue effects. And this is very crucial to the reliability of modules in internal electrical connections. For TC chamber and its temperature fluctuation, sorry guys. So the temperature fluctuation of our TC chamber is less and equal to plus and minus 0.5 degrees Celsius, and its deviation is greater or equal plus and minus 1 degree Celsius. The MQT12 humidity freeze test. So the humidity freeze test basically is just to simulate the actual outdoor working environment of the modules and solar cells and other materials. And we will conduct a damp heat test and humidity freeze test and temperature cycling test inside this one chamber, inside the same chamber. This chamber is a 3-in-1 chamber. And this test purpose is to confirm that the modules can withstand the random temperature changes in the real time, such as high temperature and high humidity, as well as its alternation in the agent caused by repeated temperature changes. In this chamber, the same parameters, the temperature fluctuation is less than equal and plus and minus 2.1 degrees Celsius, and its temperature deviation is plus and minus 1 degree Celsius. So the last environmental chamber is our damp heat test chambers. And with this chamber, it can do the test under MQT 13 damp heat test. Yes. The damp heat test basically is to verify and to determine the module's ability to withstand long-term moisture penetration. And this chamber also you can do in another test is PID test. You just have to connect to with our PID power supply, and then you can perform PID test within the same chamber. This one is current continuity test system, and this one is made to pair with other environmental chambers to conduct the test, the test procedure under IEC 61215's MQT11, MQT12, and MQT13. Yes. This device is to pair with the chambers to determine its module's reliability of the internal electrical performance connection. Yes. And this power supply is its channels are independently made, and this is independently made, and its other perks is that you can monitor the voltage by real time, and its voltage accuracy is 0.2% minus a plus and minus 240.